In this video, we are going to learn how to find dimension of physical quantities in physics. Alright, so ensure you stay to the end of this video. I'm going to simplify everything. Okay, so it's important you note that the essence of dimension of physical quantities is to show how a derived quantity can relate to the fundamental quantities of mass, length, and time. Alright, so having known this, let's look at examples. What if we are asked to find the dimension of velocity? So how do you go about it? As we all know, velocity is calculated using displacement over time. Alright, now when you talk about displacement, you're talking about the length of something, right? That means it will be measured using length, whereas the time will remain the same, since you're looking at how this derived quantity will relate to this parameter we have here. So this will be the dimension of velocity. It's either you leave it this way or you leave it like this, length per time. It's mostly like this, alright? So this is the dimension of velocity. Now let's look at another example. What if we are asked to find the dimension of acceleration? Okay, acceleration is calculated using velocity over time. Now, and you know, velocity is over time, and we know that when we talk about this time, we're talking about length, right? Length. This time around, we now have two time in this expression. That means length over t square, and this will be the dimension of acceleration. Let's leave it like this. This is how it is normally expressed. We don't normally leave it in this format. They leave it in this format, length per time square. So this is the dimension of acceleration. Alright, so what if we ask to find dimension of force? What would be the dimension? So force is calculated using mass times acceleration. Alright, since mass is relating to this, the mass will remain the same. So we have mass times acceleration. Dimension of acceleration here, we have it to be length per time square. Alright, so this dimension of acceleration. So when you add everything together, you're going to have dimension of force to be mass times length times per time square. Alright, this is 2. This is dimension of force. Alright, so let's write this and solve another example. What if you're asked to find the dimension of momentum? Alright, so momentum is calculated using mass times velocity. That means, remember, we are looking at how these derived quantity relate to mass, length, and time. That means mass will not change because mass is relating to this. So we have it to be mass times the dimension of velocity. We had it to be, this is velocity equals displacement over time, which will be length over time. That length per time. So it will be mass times length per time. So when you bring everything together, it will be mass times length per time. And this is the dimension of what? Momentum. Alright, so what if we are asked to find the dimension of density? What is it going to be? Density is calculated using mass over volume. So mass will remain the same. Volume is that length cube. Volume is length times breadth times height. So everything here is talking about length. That's why we have 3 lengths there. That's why we have length cube. So when you express it this way, it's going to be mass per length cube. So this will be the dimension of density. Let's write this and solve another example. Okay, what if you ask to find dimension of pressure? Alright, pressure is calculated using force over area. Alright, and force is mass times acceleration. Force is mass times acceleration, right, over area. Now remember, we got the dimension of force to be mass times length times per time square. Let me show you. Force equals to mass. Mass will not change since mass is related to m. We have mLT. So mass is related to m here out of the L and T. So mass is related to the m here. Alright, then mass will not change, and acceleration is velocity over time, and velocity we're talking about displacement over time. So we have two time here, right? And this v and d are talking about length. So we have length per time square. That's how we got this. Alright, so don't be confused. So the dimension of force is mass times length times per time square. Alright, over area is talking about length times breadth. Right, that's how you calculate area. Length times breadth. Okay, that means we have two lengths here. So dimension is length square. That will be the dimension. Alright, so we have mass times length per time square over length square. Alright, so when you do the applying the CC, indices states that when you're having two bases that are the same, like L is here, so they're the same, and they're dividing each other. When the law of indices, you subtract their power. So this is going to give us mass times length 1 minus 2 times per time square. Alright, so when you simplify, you're going to have mass times per length times per time square. Alright, this is per length, and this is the dimension of pressure. So let's solve one more example, and after we can call it a class. Or if you're asked to find dimension of power. Alright, as we know, the power is calculated using work over time. Alright, and work can be calculated using force times distance over time. Alright, now dimension of force, we have it to be mass times length times per time square, then times this distance here is talking about length, this distance here talking about length, then over time. Alright, so we are going to have, when you simplify this, we're going to have mass times length square, this length times in this length, we have length square, then times per times square, alright, minus 1, because the base is enough time and time here, so they are dividing each other, subtract the power. So when you simplify this the more, you're going to have the dimension of power to be mass times length square times per time cube, and this is the dimension of power. So guys, this is basically how you can solve problems or find the dimension of physical quantities in physics. I hope that's something interesting. And with this, we have come to the end of this class. If you are new to the channel, make sure you hit the subscribe button now to subscribe to the channel for more videos. Also like, share, comment on this video to tell me how you forgot what to learn from this class. If you seem to have any specific question to ask, feel free to leave your question in the comment section below, and I'll be sure to give you a response. That's it for this class, guys. Thanks for watching.